substance. Pure substance is an element or a compound that is made up of only one substance. Now, how do you distinguish a pure substance from any other substance? So pure substance will have a fixed melting and a boiling point, and finding the melting and a boiling point will provide the test for purities. Impurities makes the substance impure and alters the melting and the boiling point. Generally, impurities lower the melting point but increases the boiling point. But the pure substances are not always useful, because in pure substances, you do not find all the properties that you require. So you need to mix a pure substance by some other substances and make a formulation. Now, what is a formulation? Formulation is a mixture made to make it useful for the mankind. For example, fuels, cleaning agents, paints, medicines, alloys, fertilizer, foods. These are the various examples for formulation. Now, paint has a color mix in it, a binder, and a solvent. Fuel is a mixture of different hydrocarbons. Cleaning agents has a base mix to it and a water absorbent. Alloys is a mixture of two more metals. Fertilizers is a mixture of many minerals, and food is a mixture of very many components. So these are the examples for formulation, and they're very important for the medical and the food industry. Now, there's another way where you can find the different components of a substance by chromatography, and we discussed that a little bit in paper 1, that in chromatography, the components in a mixture are separated on the basis of solubilities of different components of the mixture in a suitable solvent. Now, how do we do this chromatography? You must have done it in school. You take a paper, you mark a line with the pencil, and touch the substance you want to separate with a kind of a capillary tube. Now, by a capillary action, the solvent travels up, and as it travels up, it dissolves the components of a mixture and separates it on the basis of its solubility. The component of the mixture which is more soluble in the solvent will travel greater distance and will leave it mark near the top. The component which is less soluble will leave a mark near the bottom. Now, how do you calculate the different components? You calculate the retention factor. Now, retention factor is a distance traveled by your component divided by the total distance traveled by the solvent. For example, in this figure, if you see L is the distance my solvent has traveled, and S is the distance my component has traveled, so retention factor is S over an L. Okay, so in the exam, they can give you a chromatogram with different distances. They can ask you to find the retention factor. You should know the principles of chromatography and how it is done. Okay, next is very important, the test for various gases. And you should know the test for hydrogen, oxygen, carbon dioxide, and chlorine. Now, where is hydrogen produced? If you remember group 1 reaction, whenever any metal reacts with acid, it forms a salt and hydrogen. And how do we test it in hydrogen? We bring this lightened splint at the mouth of the test tube, and we'll see it burns with a pop sound. So it's a squeaky pop test. For an oxygen is produced during electrolysis of water, or you decompose hydrogen peroxide. You bring a glowing splint near it, and it will relight. So observation is relighting of the glowing splint is a test for oxygen. Now, carbon dioxide is produced in a combustion reaction or whenever a carbonate reacts with an acid. And the test for carbon dioxide is you pass it to the lime water, and it will turn lime water milky. And what's the test for chlorine? Chlorine is produced in the electrolysis of brine. We discussed that in paper 1 electrolysis topic. So whenever you bring a damp blue litmus paper, you can see it is bleached. So it bleaches the blue litmus paper. Now, you should know the test of all these gases and where these gases are produced. Now, we need to know what are the tests for cations, that is the metal ions. Now, the first test that we do for any cation is the flame test. So, we take a nichrome wire and we dip it in concentrated hydrochloric acid and heat it. We then again dip it in acid and then dip it in a metal compound, and then we touch it on a roaring blue flame of the Bunsen burner, and we see, can you see there's a red color flame coming up? The color of the flame is characteristic of a metal. For example, copper ion produces a blue-green flame, potassium K+ produces a lilac flame, sodium produces a yellow flame, lithium produces a crimson flame, and calcium produces a red flame. So you should remember these ions. Now, there are certain metal ions which are not distinguishable by this test for cation, this flame test. So we have an alternative test, which is we add aqueous sodium hydroxide and we see the precipitate. Now, whenever we add an aqueous sodium hydroxide, we either see a white precipitate or a colored precipitate. If there's a colored precipitate of blue color, it is of copper. If it is of light green color, it is of iron 2+, and if it is of reddish brown, it is iron 3+. You should remember these ions and their solution and add sodium hydroxide to it and see the precipitate. If there's a colored precipitate, we note the color. Light blue is the precipitate for Cu2+ ion, light green is for iron 2+, and reddish brown is for iron 3+. When it is a white precipitate, it is for aluminium, magnesium, and calcium. Now, how do we distinguish between all these three white precipitate? We add excess sodium hydroxide and the aluminium precipitate will dissolve. On the other hand, magnesium, calcium will not dissolve, and then we can do a flame test. The magnesium will not produce any color, but if you remember, the calcium was having the red color. Okay, and then we can distinguish between aluminium, magnesium, and calcium. Now, after the metal ions, you should also know what are the non-metal ions or the anions present in your salt. Now, anions could be carbonates, halides, and sulfate. For carbonate, what we do is we add dilute acid and we see the effervescence, and that effervescence is for carbon dioxide. Now, to confirm that is for carbon dioxide, we pass it through lime water and the lime water should turn milky. On the other hand, for the test of chloride and bromide and iodide, we do a silver nitrate test. We add dilute nitric acid and then we add silver nitrate solution and we note the color of the precipitate. If the precipitate is yellow, then it means iodide ions are present. If the precipitate is cream, then the bromide ions are present. If the precipitate is white, then the chloride ions are present. For the test of sulfate, we add dilute hydrochloric acid and then add barium chloride solution and we see a white precipitate. Why there's a white precipitate? Because barium and the sulfate ions combine to form barium sulfate, which gives a white precipitate. So you should know all these ions test and how we perform them. Next is, what is an instrumental analysis? Now, whatever we did so far was a chemical test, which was qualitative, where we are destroying the original sample by mixing something to it, and it is less accurate and sensitive, and it does not give any quantitative information. On the other hand, there's an instrumental analysis, which is quantitative, where original sample is preserved, which is more accurate, fast, and sensitive. And one instrumental analysis is flame emission spectroscopy. Now, each metal forms a characteristic line spectrum when it is placed inside a spectrometer. So we take a sample, place it inside a spectrometer, we get the line spectrum, we measure the absorbance value that gives us the concentration of the metal ions, and then we compare it with the database, and that can give us information about the traces of the metals as well. So you should know the advantages of the flame emission spectroscopy and what exactly is it. Okay, so I hope this topic is clear to you. Now you should be able to define these terms. What is a pure substance? Fixed point, formulation, chromatography, mobile phase, stationary phase, chromatogram, retention factor, flame test, instrumental analysis, and flame emission spectroscopy. If you still cannot define these terms, watch this video again, pause this video, have a go of this, and then you can check back on the website for the answers of this. Okay, so as always, what's our next step? Our next step is to check the specification and do exam questions on this topic. And you can get these exam questions on this topic on my website. The link is mentioned in the description box below. If you like this video, do not forget to subscribe to our channel. And there's a small bell icon next to it. Do click on that so that you get notified whenever I put up a new video. And I promise you, I'll be putting a lot of useful videos before your exams. Also, if there's anything that's not clear to you, you can leave a comment below. Or on my website, there's a 24/7 chat spot where you can post any of your queries and get instant replies by me. Okay, so I'll see you next in the next video. And if there's any specific video you want me to make a video on, then also leave a comment below and I'll make sure I'll make that up before your exam. So I'll see you next in the next video. Till then, happy revising.